Bismillahirrahmanirrahim. Assalamu alaikum students. This is Tariq. In the previous lecture, we were learning discrete probability distribution function. In this section, we will learn about the binomial discrete probability distribution function. What does this binomial discrete probability distribution function mean? This means that we can use binomial discrete probability distribution function to assign probabilities to the values of the random variable of an experiment which carry the following characteristics. Binomial discrete probability distribution function is applicable to an experiment which carry the following characteristics. The first characteristic is this: multiple step experiment which carry n number of identical steps or trials. Means the experiment must be multiple step experiment and number of steps or trials of the experiment must be same, identical, mushabeh. So this is the first characteristic of the binomial experiment, that steps must be multiple, many steps, and steps must be identical. Second characteristics of the binomial experiment: each step carry two outcomes, success and failure. Second characteristics of the binomial experiment is this, that each step of the experiment must carry two outcomes, success and failure. Third characteristic of the binomial experiment: the probability of success and failure is same for all steps or trials. Means that the probability of success of outcome must be same in all steps of the experiment, and similarly the probability of failure must be same in all steps of the experiment. For example, the outcomes of the steps are independent. The outcomes of the steps are independent means that if we toss a coin and in the first toss head appear on the up face of the coin, so second toss outcome does not depend on the first toss outcome. First toss outcome is head. It does not mean that the second toss outcome will tail. No, it does not. Outcomes does not depend on each other of each step. So steps are outcomes of the steps are independent, or we can say trials or steps are independent. It does not mean that in the first step head appear, so in the second step will tail appear now. No, this is possible that in the second step again head appear. This is also not that if in the first step head appear, so in the second step will again head appear. No, this is not sure. So outcomes of the steps, the tosses are independent. Let me clarify these characteristics of the binomial experiment by putting one example. Suppose toss a coin twice. So tossing a coin is experiment, and now we are tossing a coin twice, so this is multiple step experiment. First characteristic satisfied, that steps are more than 1, 2, and each step will carry two outcomes. Each steps are identical. Toss a coin one time and toss a coin again second time. And second characteristics, toss a coin twice. Each toss will carry two outcomes: head on the up face of the coin or tail on the up face of the coin. And third, the probability of head and the probability of failure in both tosses is same. And the fourth, the outcomes of the steps are independent. It does not mean that when we toss one time, so head appear, so when we toss second time, again head will appear. No, maybe that second time when we toss, tail appear. This is possible that when we toss first time, head appear. This is possible that second time toss, again head appear. This is possible that second time toss give us tail. So the outcomes of the trials, the steps are independent. So look, if a particular experiment carry these four characteristics, so this experiment is called binomial experiment, and to assign probabilities to the values of the values of the random variable of the binomial experiment, we are using binomial discrete probability distribution function. And now this is the mathematical notation of the binomial probability distribution function. We will use this formula to assign probabilities to the values of the random variable of binomial experiment. I am interpreting where capital N is the total number of steps or trials of the experiment, where small n is the total number of successes of experiment, where p is the probability of success of outcome, where q is the probability of failure of outcome. Suppose the probability of success is 30%. So when the probability of success is known, we can find the probability of failure from here. Q is equal to 1 minus 0.30. When we subtract from 130%, the probability of failure we calculate, that is 70%. So this formula we will use to assign probabilities to the values of the random variable of the discrete binomial experiment. Now we are further clarifying by putting one example. For example, develop the discrete probability distribution for the discrete random variable success of conducting 3 exams. Suppose in this example, our experiment is conducting exam, and the question is this, that develop discrete probability distribution for experiment conducting exam, but exams are 3, mean experiment is multiple step experiment. Look, this is very clear from this table. Experiment conducting 3 exams. So first characteristic of the binomial experiment satisfied, that this is multiple step experiment. And second, that when we conduct exams, so every experiment carry 2 outcomes. Every exam carry 2 outcomes. Success mean pass exam or failure. So we will consider the discrete random variable success in this example. Means I am going to assign probabilities to the number of successes of 3 exams. So our discrete random variable is number of success, and this is the values of success. We define the discrete random variable mathematically 0, 1, 2, 3. So that is why success is random variable and it can assume specific value. That is why this is discrete random variable. Let me again repeat. That example is this: develop the discrete probability distribution table for experiment which is multiple step conducting 3 exams. So this is binomial experiment? Yes, because satisfied the characteristics. First characteristic, this is multiple step experiment. Second, each exam carry 2 outcomes. Each experiment carry 2 outcomes. Third, the probability of success and failure is same in each exam. Fourth, the outcomes, the success and failure in each experiment are independent. It does not mean that if the student passed the first exam, so he will pass the second exam as well, the third as well. No. Outcomes are independent. Outcomes of the steps are independent. So this conducting 3 exam experiment is binomial experiment because it satisfies all the 4 characteristics as this is given in here. This is multiple step experiment. Steps are identical. Each step carry 2 outcomes: success or failure, pass exam or fail exam. The probability of success and failure is same in each steps, and steps are independent. So this example, this experiment conducting 3 exams satisfy all the 4 characteristics of binomial experiment. So it's mean we can use binomial discrete probability distribution function to assign the values to the discrete random variable, to assign the probabilities to the values of the discrete random variable success. So I am assigning probability of 0 success. How we can estimate, how we can calculate, how we can assign probability to the 0 success. Suppose probability of success is 30%, 0.30. So when the probability of success is 30%, when the probability of passing exam is 30%, so what is the probability that he will fail exam? 70%. So we can find the probability of failure using the probability of success. 1 minus 30% is equal to 70%. So this is P, the probability of success, as this is very clear from here, where P is the probability of success, where Q is the probability of failure. So the probability of success is given to us, known to us, 30% chances that student will pass exam. So what are the chances that student will fail exam? Q, the probability of failure, 70%. The number of steps, capital N, represent number of trials, number of steps, number of exams, 3. And N, the number represents small n, represent number of success. So 0 success mean student does not pass even a single exam. So what are the chances that student will fail all exams, or what are the chances that student will pass 0 exams? So we will just put the values in the discrete binomial probability distribution formulation. This is the discrete binomial probability distribution formula. We will put the values P represent probability of capital N steps, small n success, N, and P raised to the power n multiplied by Q raised to the power n minus n. We will just put the values. Number of exams, capital N 3, we put in here. Small n 0, number of success 0. So 30, probability of success P is 0.30 raised to the power small n is 0 multiplied by Q 0.70 raised to the power capital N 3 minus small n 0. And now probability of 30 is equal to 30. Anything raised to the power 0 is equal to 1. So 0.30 but 1 is 0 is equal to 1 multiplied by 0.70 raised to the power 3. 3 minus 0 is equal to 3. Now this is very clear, but what this 30 mean? This means that how many combinations of 0 success are possible. If we are counting the experimental outcome, the experimental outcomes of binomial experiment in combination form of 0 success, so how many combinations are possible? We will use the counting rule for combination to define the number of combinations of 30. So I am using in here, determine the number of combinations of 0 successes. So counting rule for combination C, capital N small n is equal to n factorial whole divided by n factorial multiplied by n minus n whole factorial. Now C30 is equal to capital N is 3 factorial divided by 0 small n 0 factorial 3 minus 0 whole factorial. C30 is equal to 30 is equal, this implies 3 factorial, and this is 0 factorial, and 3 minus 0 3 factorial. So C30 implies 30 implies 3 factorial, as it is 0 factorial is equal to 1, so 3 factorial. Now C30 is equal to 30 implies 1. 3 factorial divided by 3 factorial is equal to 1. So the number of combinations of 0 successes is F. All 3 exams fail. Now we will replace, we will substitute for 301 in here. For this 301 we will replace 1. So as this I am replacing, putting C30 is equal to 30 is equal to 1 in the below equation we have. So we are putting for 301 and 1 steric 070 raised to the power 3 as it is. P30 is equal to 1. 1 multiplied by 0.70 raised to the power 3 will give us this value 0.343. And now P30 is equal to 1 as it is. 1 multiplied by 0.343 is 0.343 and probability of 30 is equal to 0.343. What does this mean? What is interpretation? This means 34.3% chances that student will fail all exams, or student will does not pass even in a single exam, or 34.3% chances that student pass 0 exams. Now the probability of one success. So the probability of success is 30%, failure 70%, capital N 3, number of steps, and number of successes 1. By putting the values in the formula we have probability of 31, probability of success 0.301 and probability of failure 0.703 minus 1. So probability of 31 is equal to 31. 0.30 multiplied by 0.70 raised to the power 2. Now again we will use the counting rule for combination to determine the number of combinations of one successes out of the total 3 exams. That how many combinations are possible if student is passing only 1 exam out of the total number of exams 3. So determine the number of combinations of one success. We will just put for capital N its value 3, for small n its value 1, and 3 factorial divided by 1, 3 minus 1 whole factorial. C31 is equal to 31 implies 3 factorial divided by 1 factorial and 3 minus 1 2 factorial. C31 implies 3 factorial. We will expand 3 factorial. 3 multiplied by 3 minus 1 whole factorial divided by 1 factorial is equal to 1, and this is 2 factorial. So C31 is equal to 31 implies 2 factorial divided by 2 factorial. 2 factorial cancel out with 2 factorial and 31 is equal to 3. It's mean 3 combinations are possible out of the 3 total exam that student pass only 1 exam, and these combinations are as given. Number of combinations of one success. First exam pass and the other 2 fail. First fail, second pass, third fail, or first 2 fail, third pass. So these 3 combinations are possible. The total number of experimental outcomes of an experiment, if the statistician want to determine the experimental outcomes in the combinations form. Now we will replace for 3 its value 3 in this formula in here. We will replace in here for this 3 its value 3. So I am replacing P31 is equal to 3, 0.30 multiplied by 0.70 raised to the power 2, and P31 is equal to 3, 0.30 multiplied by 0.49, 0.70 raised to the power 2 is equal to 0.49, and probability of 31 is equal to 3, and 0.30 multiplied by 0.49 is equal to 0.147. Probability of 31 is equal to 3 multiplied by 0.147 is equal to 0.441. Interpretation: 44.1% chances that student will pass only 1 exam, mean 44.1% chances that student pass only 1 exam. So this is the probability of 1 success. Now we will proceed toward the probability of 2 success. Again, probability of success is 30%, which is given. Probability of failure, that is 70%, again this is given. Number of exams 3 and number of success 2. So by putting the values in the formula we have probability of capital N 3 success 2, 2, probability of success 0.30 raised to the power 2 multiplied by 0.70 raised to the power 3 minus 2. Probability of 2 is equal to 2 as it is, 0.30 raised to the power 2, 0.09 multiplied by 0.770, 3 minus 2, 1. Now again we will use the counting rule for combination to determine the number of combinations of two successes out of the 3 exams. So Cnn is equal to n factorial divided by n factorial multiplied by n minus n whole factorial. We will just replace the value for n and small n, 3 factorial divided by 2 factorial 3 minus 2 whole factorial. C32 is equal to 32 implies 3 factorial, 2 factorial 3 minus 2 1 factorial. C32 is equal to 32 implies 3. I am expanding this 3 factorial, 3 multiplied by 3 minus 1 whole factorial divided by this 2 factorial, and 1 factorial is equal to 1. So 2 factorial multiplied by 1 is equal to 2 factorial. Now C31 is equal to 31 implies, this is C32, sorry, this is not 1, 32 implies 3, and this is 3 minus 1, 2 factorial divided by 2 factorial. 2 factorial cancel out with 2 factorial, and C32 is equal to 3, means the number of combinations of 2 success out of 3 exam is 3. So we will replace for 3 in this formula in here. I am putting for this 3 its value 0.09 multiplied by 0.70, and probability of 3 is equal to 3 as it is. 0.09 multiplied by 0.70 is equal to 0.063, and probability of 3 is equal to 0.189. What does this mean? This means 18.9% chances that the student pass 2 exams out of 3. Now the probability of 3 success. Again the probability of success 30%, failure 70%, number of exams 3, number of success 3. We will just replace in the formula binomial discrete probability distribution function. For capital N its value 3, for small n its value 3. So 0.30 raised to the power 3 and 0.703 minus 3. Probability of 3 is equal to 0.027 multiplied by 0.70 raised to the power 0. Now the number of combinations of 3 success, we will use the counting rule for combination, and how many success? 1 success is here. So means the number of combination that student pass all exam, that is 1, and this number of combination is as given in here. This is not 3, sorry, this is wrong. Number of combination of 3 success, SSS. So one outcome is possible that we write all 3 successes in one combination form. So we will replace by putting C33 or 33 is equal to 1 in this formula. We have probability of 33 is equal to 0.027 multiplied by 0.70 raised to the power 0. Probability of 33 is equal to this. C33 is equal to 1, so we replace 1 in here because the number of combinations of all 3 successes is only 1 outcome. So we replace 0.027 multiplied by 1 multiplied by 0.027, and P33 is equal to 0.027. What does this mean? This means interpretation. 2.7% chances that student will clear or will pass all 3 exams. 2.7% chances that student pass all 3 exams. We distribute one probability over the value 0, 1, 2, 3 of the discrete random variable. Now this is probability distribution table. Discrete probability distribution function develop this table for conducting 3 exams and list the value of the random variable success and list the probabilities of the values of the random variable success. So look, this is the first value of the random variable success 0, 1, 2, 3, means the first column represent the values of the discrete random variable success, and the second column represent the corresponding probabilities of the values of the discrete random variable. So 0.343 is the probability of 0 success, 0.441 is the probability of 1 success, 0.189 is the probability of 2 success, 0.027 is the probability of 3 success. When we add all these probabilities, this is equal to 1. So binomial discrete probability distribution function divide this one probability over the 4 values of the random variable. This is the definition of the discrete probability distribution function. That discrete or binomial discrete probability distribution function divide one probability over the values of the random variable. So 34.3% chances 0 exam pass, 44.1% chances 1 exam pass, 18.9% chances 2 exams pass, and 2.7% chances that all 3 exams cleared or passed.